This is part 2 of the in-class review for the Quadrilaterals quiz/test, larger than a quiz, smaller than a test. I just didn't want to have an hour-long video in case something screwed up. So I split it in 2 parts. The first part was the first page, 1 through 12. The second part is the second page, 13 through 22. So 13, we have a rhombus. So I'm going to draw a rhombus. What I'm going to do here is put all the sides congruent because I know a rhombus has all sides congruent. So this is E, F, G, and H. Once again, we want to order when we make our drawing, we want to go in order, clockwise or counterclockwise. We don't want to skip diagonally. So we don't want to do E, F, G, H. We want to do E, F, G, H clockwise or counterclockwise. Don't skip across diagonally when you're drawing your diagram. E, G, and F, H should be your diagonals. Okay. So in this rhombus, it's saying angle E is 3x minus 10. And it's saying F is 4 times the quantity x minus 35. Find the measure of angle G. Well, a rhombus is a parallelogram, and we know properties of parallelograms tell us that consecutive angles are supplementary. So these F and E are, angle F and angle E are consecutive angles. So they're going to be supplementary, meaning they're going to add up to 180. So we can add those two values, 3x minus 10 plus 4 times the quantity x minus 35 are going to equal 180. We have to distribute, so 3x minus 10, distribute the 4 plus 4x, minus, that's 70, so 140 minus 140 equals 180. Combine like terms, we're going to get 7x minus 150 equals 180. You sure about this? What do you have? 3x minus 10. 4x minus, that's 70, 140. Add 150. Oh, we're adding. Doesn't matter. Again, decimals are fine. I just didn't think we'd have decimals. So 7x is going to, we're adding, so we're going to have 330. I assume 7 goes into 330 evenly. So that's 4. Oops. 28. That's going to be 50. Really? Okay. It's fine. No big deal. Well, then we can just say x is 330 over 7. Let's make sure we did this right. 150, 330. Yeah. Four times 7 is 28. Okay, so x is 330 over 70. Just seems odd. I guess they want decimals. So we know angle E and angle G are opposite angles, so those angles are going to be congruent. So angle E, if we substitute in, is going to be the same as angle G. So this is also going to be 3x minus 10. So to find angle G, we're going to substitute in 330 over 7 subtracted by 10. $330 times 3 is 990 over 7 minus 10. So we can make that minus 990 over 7 minus 70 over 7, which is going to give us 920 divided by 7. Just out of curiosity, let's see if 7 goes into 920. Once. 22, 3 times. No. So 920 over 7. That's the measure of angle G. Just put it in the calculator, find a decimal is fine. We did it right. Confident we did it right. 3x minus 10. 4 times x minus 35 is 4x minus 140. 7x minus 150. Add 150, divide by 7, put it in, 990. Yep, 920 over 7, we're fine. Okay, 14, we have a rectangle. See, I think that's the process you guys should take when you get a decimal, because you guys always ask, can we get decimals, can we get fractions? The answer is yes, you can, but it's not very likely. Usually these problems are going to work out to be even numbers. Again, I haven't done this problem yet, so I expected an even number. We didn't get an even number, so I double checked. But it's okay. We didn't get an even number. That's fine. It's perfectly fine. We did the problem right. We could have substituted back in. So usually not going to get a fraction or a decimal, but it's perfectly fine to do. Just double check, triple check. Okay, 13, we have a rectangle, A, B, C, D. AB, first of all, we know rectangles have right angles. Not sure if that's going to help us, but let's put it in because that's how we define a rectangle, as a parallelogram with 4 right angles. Okay, AB is x minus 3. BC is 24. AD is 2x plus 12. Find the perimeter. Okay, we can find the perimeter. We know opposite sides are congruent. Oops. So we know AB is congruent to CD, so we know this is also x minus 3. And we know BC is congruent to AD, so we can set up an equation. 2x plus 12 equals 24. Subtract 12. 2x is going to equal 12 divided by 2. X is going to equal 6. We can find our 4 sides. So 6 minus 3, it gives us 3. 6 minus 3 is 3. 2 times 6 is 12. 12 plus 12 is 24. And the perimeter is the 4 sides added together. It's the length around the exterior. So if our perimeter, we're finding the perimeter. So our perimeter is going to equal our 4 sides added together. So that's 6 plus 6 plus 24 plus 24. That's going to give us 12 plus 48, which is going to give us 60. Our perimeter is going to be 60. 15, we're given a parallelogram, frog, so F-R-O-G. Parallelogram, F-R-O-G. The measure of angle G is 2x plus 10. 2x plus 10. Measure of angle R is 8x minus 30. Find the value of x to the nearest hundredth. I'm just going to find it as a fraction. Find the measure of all the angles. So we know in a parallelogram that the opposite angles are congruent. So 8x minus 30 is going to equal 2x plus 10. Subtract 2x. 6x minus 30 equals 10. Add 30. 6x is going to equal 40. Divide by 6. X is going to be, what is that? So 40 over 6, which is going to give us 20 over 3. Which is going to give us 6 point. Well, that's an interesting number. 6.66, or round up to 6.7. Who made this? What were they trying to do? Right, because you get 6.66666. We can round that to the hundredth place, so 6.67. Find the measure of all the angles. So angle G is going to be 2 times 20 over 3 plus 10. So this is 40 over 3. Common denominator, so 30 over 3. So 70 over 3. So this is 70 divided by 3. This is 70 divided by 3. Right, we should get the same thing. 8 times 20 over 3 plus 10. So that's 160 over 3. Plus 30 over 3. So that's 190 over 3. Oh, I'm sorry. What am I doing? Minus 30. Minus 30. So minus 90 over 3. Common denominator equals 70 over 3. F and O, we have to do 180 minus this angle because they're consecutive angles, which are supplementary. So 180 minus 70 over 3. So that's 360. Plus 180, 540. Which is going to give us 470 over 3. So 470 over 3. 470 over 3. Whatever that is a decimal. 16, we can scroll down and do 16. I'm getting tired. It's 7:09 right now. I'm getting tired. I'm sorry. I can feel myself not explaining things as well or as efficiently as I should be. But again, I've been at school for 13 hours now. Well, I left school briefly to go to the SciOp PD, but I came back to do the video. So essentially 13 hours. All right. Okay. Focus on the last 7 problems here. All right. Is the figure below a parallelogram? Explain. If so, find the measure of the angles. If it's a parallelogram, the opposite angles are congruent, but that's not going to help us because those would just cancel out if we made an equation. So we got to use the property that consecutive angles are supplementary. So consecutive angles, we have x plus 10 plus 5x minus 4 is 180. Okay, consecutive angles are supplementary. 6x, combined like terms. 10 minus 4 is 6. Subtract 6. 6x equals 174. Divide by 6. 29, I believe. That's 2. 54. It's going to be 9. 29. So it's asking, is it a parallelogram? It should be, but let's check and make sure when we plug in, when we substitute back in. So we're going to get 39. Can we see on this? We get 39. Here we're going to get 5 times 29. So 5 times 30 is 150. 150 minus 5 is 125. And then 125 minus 4 is 121. I'm sorry, 145 minus 4 is 141. So yes, this is 141, this is 39. Yes, this is a parallelogram. Okay, number 17, given the rhombus below ABCD, find the value of x and y. So we have a rhombus. We know a rhombus is a parallelogram. Okay. We know in parallelograms, consecutive angles are supplementary. Okay. So these two angles, this whole thing here has to be add up to 180. Consecutive angles are supplementary. So if we do 180 minus 68, we're going to get 112. So we know this whole thing has to be 112. In rhombuses, we know the diagonals bisect opposite angles. So we know we're bisecting angle DCB. So we know these two angles here are going to be half of this. So if we divide by 2, we get 56. So we have 56 and 56. Because it's a rhombus. Again, if this was a parallelogram and not a rhombus, just a parallelogram, we can't bisect that angle. But since it's a rhombus, one of the specific properties of a rhombus is that we're bisecting the opposite angles. Then, since it's a rhombus, it's a parallelogram, so we have DC is parallel to AB, and AD is parallel to BC, so we can use alternate interior angles. The alternate interior angle theorem, which says if the lines are parallel, alternate interior angles are congruent. So we get 56 and 56. So x and y are both going to be 56. X is 56, y equals 56. Number 18, we have a parallelogram to contrast this, because on the test, again, we've done this multiple times. We're giving you one example and then the other. I don't want you guys bisecting the parallelogram. I just feel that's what people are going to do. We know opposite angles are congruent in parallelogram, so y is going to be 112. We know these two angles, or these two, whichever pair there, they're going to be consecutive. And we know in parallelograms, consecutive angles are supplementary. So 180 minus 112 is going to give us 68. Again, it's not 40 and 40. It's got to be 68 minus 40. Which is 28. And then it's a parallelogram, so opposite sides are parallel, so we can use the alternate interior angle theorem, which says that if the lines are parallel, the alternate interior angles are congruent. So x is 28. This one here will be 40. The distinction here is in a rhombus, the diagonals bisect the angles. Here, in a parallelogram that's not a rhombus, the diagonals do not bisect the angles. That's 18. Almost done, guys. 19, 20, 21. And then we'll do 22. So trapezoids. One of these in 19 is isosceles, one is not. We know the second one's isosceles because we have AB congruent to CD. The other one is not. The only property we have for a trapezoid that is not the only property we have for a trapezoid that is not an isosceles trapezoid is that the consecutive angles between the bases are congruent. So the parallel sides indicated by these arrows say that RS is a base and QT is a base. So the consecutive angles between the bases are supplementary. That's the only property we have for a trapezoid that is not an isosceles trapezoid. So we know these two angles add up to 180. They're telling us this one is 78. So 180 minus 78 is going to give us 102. So we know the measure of angle R is 102. Right? Can we see this? I'm in the way. Kind of. 78 and 102. This angle we know is 132. So 180 minus 132 is 48. So we know the measure of angle T is going to be 48. The consecutive angles between the bases are supplementary. B is an isosceles trapezoid. So we know again, our bases here. This is 10x, that's 10x plus 20. Can't see it on here, it's too small, but on your sheet, we should be able to see those. We know the consecutive angles between the bases are supplementary, so we know that 10x plus 10x plus 20. So here's one angle, here's the other. They're supplementary, so they add up to 180 because they're consecutive angles that are between the bases. Consecutive angles between the bases are supplementary. Combine like terms, we have 20x plus 20 equals 180. Subtract 20. 20x is going to equal 160. Divide by 20. X is going to equal 8. We can now substitute that back in. This angle is 10x. 10 times 8 is 80. So we know the measure of angle B is 80. Measure angle A, the measure of angle A is 10x plus 20. So 10 times 8 is 80. 80 plus 20 is 100. So angle A is 100, right? This is 10 times 8 plus 20, which is 80 plus 20, which is 100. This one is just 10 times 8, which is 80. So that's A, and this is A, and that's B. The other property we know for isosceles trapezoids are that the base angles are congruent. So here's B and C are base angles, and A and D are base angles. So B and C are base angles, so B and C are congruent. So they're going to have the same angle measure. A and D are base angles. Base angles in isosceles trapezoids are congruent. So their measures are going to be equal, so it's also going to be 100. The key difference here, let me erase all this. The key difference here, I try to keep everything else, is that, so this is 80, 80, 100, and 100. Okay. When it's not isosceles, the base angles are not congruent. When it is isosceles, the base angles are congruent. I'm telling you right now, this is what some of you guys are going to screw up on the test. When you're given one like this, you're just going to put the base angles to be congruent. You can't do that. Only if it's isosceles are the base angles congruent. In all of them, though, isosceles trapezoids and non-isosceles trapezoids, the consecutive angles are supplementary. So if you're trying to determine what you want to do, if you can, use the property that the consecutive angles are supplementary, because you're not going to go wrong there. Because for all trapezoids, consecutive angles between the bases are supplementary. Base angles are only congruent in isosceles trapezoids. Number 20. Okay, angle B is 80. Angle A is 110. So if we can't see, well, you should be able to see on your paper, but that has one hash mark, these have two. So one pair, this is a kite, tells us it's a kite. Well, it doesn't, but we know it's a kite by those hash marks, because a kite has no pairs of parallel sides and has two pairs of adjacent sides that are congruent. So here's one pair of adjacent sides that are congruent, one pair of adjacent sides that are congruent, and then a second pair of adjacent sides that are congruent, or consecutive sides that are congruent. Adjacent and consecutive can be used interchangeably here. We know that the angle, there's one pair of angles that are congruent in a kite, and those are the angles that are between the two pairs. So if one pair is up here, another pair is down here, the angle between them are going to be angle A and angle C. So we know angle A and angle C are congruent. So if angle A is 100 degrees, 110 degrees, angle C is also 110 degrees. Note that angle B and angle D are not congruent. There's only one pair of congruent angles in a kite, and those are the angles between the two pairs. But we do know a kite is a quadrilateral. A quadrilateral is a four-sided figure. We know that all quadrilaterals, so all four-sided figures, have four angles, and those angle measures are going to add up to 360 degrees. So if this is the measure of angle D, and that's what we're trying to find, we know the measure of angle D plus 110 plus 110 plus 80 is going to equal 360. So the measure of angle D plus what's 110 and 110 is 220. 220 and 80 is going to be 300. So we subtract 300 from both sides. The measure of angle D is going to be 60 degrees. So this is 60. 220 plus 80 is 300. 300 plus 60 is 360 degrees. All quadrilaterals, the four angles of a quadrilateral add up to 360 degrees. Number 21. Find the values of the variables and missing angles in the rhombus below. Okay, let's zoom in just so we have more room. So it's a rhombus. ABCD is a rhombus. So we know a rhombus has four sides that are congruent. So even if it's not going to help us or not going to be useful, I like to put them in just so they're there, so I don't forget anything. Okay, and we want to find X, Y, and Z. We know that AEB is 3x. We know that BEC is 2x plus 3y. BEC. We know CED is Z. We also know that the diagonals of a rhombus are perpendicular. This is on our reference sheet. And we know perpendicular lines are lines that form right angles. Where they intersect, they form right angles. So if two diagonals, AC and DB, two diagonals are AC and DB, our diagonals are perpendicular. That means where they intersect, we have right angles. So we have four right angles. So we have 90, 90, 90, and 90. So 3x is going to equal 90. Divide by 3. X is going to equal 30. We know 2x plus 3y is going to equal 90. Because all this angle is 90, this angle is 90, this angle is 90. We know x is 30. So 2 times 30 plus 3y is 90. 2 times 30 is 60. Subtract 60. 3y is 30. Divide by 3, we get y equals 10. We substitute those back in, we should get 90, right? So 3 times 10 is 30. 2 times 30 is 60. 60 plus 30 is 90. Okay. And then our last one, angle Z here, we know Z is also going to be 90. The second part of the question is saying that if the measure of angle ADE is 40, so we have the measure of angle ADE is 40. Okay. So we want to find the measure of all the other angles. So we know in a rhombus, the diagonals bisect the opposite angles. So if ADE is 40, we know CDE is also 40 because the diagonals bisect the opposite angles. And then we have alternate interior angles, so we know we're going to have 40 and 40. Okay. We know a rhombus is a parallelogram. So So the consecutive angles are going to be supplementary. So if we have 40 and 40, we have 80. So if we do 180 minus 80, we have 100. And if we do 100 divided by 2, we're going to get 50. So we know we're going to have 50 and 50. Alternate interior angles, we're going to get 50 and 50 as well. All right, and then the last one is 22. Bring it back out. See, it's so late that janitor's already come in twice. Cleaning up you guys' mess because you throw crap all over the floor every day. Actually, it doesn't take me that long to clean it up, but still, I clean up the big stuff. I don't understand why you guys throw stuff on the floor. It's your high schoolers. You learn in kindergarten, don't throw stuff on the floor. I don't know. I haven't thrown stuff on the floor since kindergarten. Anyways, last question. It's 7:30. Parallelograms are never trapezoids. No, a parallelogram is defined as having, so that's true. It's true that that is never the case. Okay, parallelograms are defined as having two pairs of parallel sides. A trapezoid has exactly one pair of parallel sides, so it's true that a parallelogram is never a trapezoid. All squares are rhombuses. This is true. A rhombus is defined as having 4 congruent sides. A square is defined as having 4 congruent sides and 4 right angles. So if a square has 4 congruent sides and 4 right angles, it's always going to have 4 congruent sides. So if it has 4 congruent sides, it is a rhombus. So that one is true. A rhombus is a rectangle. This is false. A rhombus is defined as having 4 congruent sides. A rectangle is a rhombus is defined as a parallelogram that has 4 congruent sides. A rectangle is defined as a parallelogram that has 4 right angles. Okay, so a rhombus is not a rectangle. I guess a rhombus could be a rectangle if it was a square, because if it's a square, it's a rhombus, but it's also a rectangle. So the one case where you could have a rhombus that was a rectangle would be if it was a square. But generally speaking, no, that's false. All parallelograms are rectangles. That's not false. That is false. All rectangles are parallelograms, but there's clearly some parallelograms that are not rectangles. For example, a rhombus is not a rectangle. So if you look at the Venn diagram, all rectangles are in the parallelogram circle. But not all there's plenty of parallelograms all out here that are not part of the rectangle circle. Isosceles trapezoids are trapezoids. Yeah, of course. They're isosceles trapezoids. But a trapezoid is defined as having exactly one pair of parallel sides. An isosceles trapezoid is a trapezoid that has legs that are congruent. So it is going to be a trapezoid. In a square, all sides are congruent. That is true. A square is a rectangle and a rhombus. So it's defined as having 4 congruent sides and 4 right angles. So since it has 4 congruent sides, it is a rhombus. And we know rhombuses have all sides that are congruent. So this one is true. Parallel sides of an isosceles trapezoid are congruent. This one is false. If they were congruent, then these sides would also be congruent, and we wouldn't have a trapezoid. We would have a rectangle or a square or a rhombus or some sort of parallelogram. Because opposite sides, if we have 2 pairs of opposite sides that are congruent, we have a parallelogram, right? One of the properties of parallelograms that's sufficient to be a parallelogram is that we have 2 pairs of opposite sides that are congruent. So if it has two pairs of opposite sides that are congruent, it's a parallelogram, which means it has 2 pairs of parallel sides. And if a trapezoid is defined, a trapezoid is defined as having exactly one pair of parallel sides, right? Exactly one pair of parallel sides. If it has two, then it doesn't have exactly one pair of parallel sides, so that one is false. All quadrilaterals have four congruent sides. This is false. A quadrilateral is defined as having four sides. They don't need to be congruent. Only rhombuses and squares are going to have four congruent sides. Well, you could have other figures too that are not convex, but we're not going to worry about that. A square is a rectangle. This is true. So all squares are rectangles. Rectangles are defined as parallelograms that have four right angles. A square is defined as a parallelogram that has four right angles and four congruent sides. So if it has four right angles and four congruent sides, it's going to have four right angles. And if it has four right angles, it is a rectangle. A rectangle is a square. This is false. It could be true. It could be true. If all the sides of the rectangle were congruent, then it would be true. But there are plenty of situations where we don't have a rectangle as a square. A rectangle is defined as having four right angles, a parallelogram with four right angles. A square is a parallelogram that has four right angles and four congruent sides. So if the rectangle had four congruent sides, then it would be a square. If it doesn't have four congruent sides, then it is not a square. And our choice here is false. Okay. That is the review, the study guide for the Unit 4 test/quiz. So bigger than a quiz, smaller than a test. Further questions, email me, ask me. I would love to help. It's 7:33. I've been here for 13 and a half hours. Good night.